በመቀጠል we look at the second chapter, which is second order ordinary differential equations. መጀመሪያ we look at the linear versions of these equations. ስለዚህ the second order ordinary linear differential equation general formaቸው በዚህ መንገድ ሊገለጽ ይችላል, which is ay double prime plus by prime plus cy is equal to f of x. እዚህ ጋር a, b እና c they are constants. ስለዚህ እዚህ ጋር f of x is equal to 0, the differential equation is said to be homogeneous, and if f of x is different from 0, the differential equation is said to be non-homogeneous. በመቀጠል we look at the different types of solutions. መጀመሪያ there's linearly independent solutions. ያው applied one ላይ እንደምናስተዋውሰው if we have a set which has elements y1, y2, y3, then this set is said to be linearly independent if the linear combination of this set becomes 0 if all the constants are also 0. ማለትም linear combination ላይ እያንዳንዱ c 0 የሚሆን ከሆነ ወይም ደግሞ 0 ብቻ ሲሆን ከሆነ linear combinationን 0 የሚያደርገው it's said to be linearly independent. ስለዚህ if we have two solutions y1 and y2, and if they are solutions of the differential equation, the general differential equation ay double prime plus by prime plus cy is equal to 0, then using the superposition principle the linear combination is also a solution. ስለዚህ በዚህ መሰረት general solution ማግኘት እንችላለን ማለት ነው. Then next we have the Wronskian test, which is a test used to determine whether two functions are fundamental ወይም ደግሞ linearly independent. ያው Wronskian ማለት it's a value determined by using the determinant of the function f g ከዛ the first derivative again the first derivative of the second function. ሶስት ከሆነ ደግሞ again determinant of a 3 by 3 matrix ይመጣል ማለት ነው. ስለዚህ በዛ መሰረት we have an example. Verify that the function f of x is equal to e to the power of minus 2x and g of x is equal to e to the power of 5x are linearly independent. ያው Wronskian ነው determine የምናደርገው. We have f which is e to the power of minus 2x and again g e to the power of 5x. The first derivative becomes minus 2 e to the power of minus 2x and 5 e to the power of 5x. ስለዚህ determinanቱ ስንወስደው 7 e to the power of 3x መጣ. We know that 7 e to the power of 3x is different from 0 for all x an element of real number. ማለትም there isn't a number in the set of real numbers such that this equation becomes true. ስለዚህ ይሄንን ዲተርማይን ካደረግን if the Wronskian is different from 0 linearly independent ነው ማለት እንችላለን ማለት ነው. Hence f and g are linearly independent. በመቀጠል ደግሞ we look at the homogeneous versions of the differential equation. እንደምናውቀው has the general form of a y double prime plus by prime plus cy is equal to 0 where a, b and c are constants. ስለዚህ እዚህ ጋር የዚህ differential equation general solution it always has the form y is equal to e to the power of rx. ስለዚህ ከዚህ ተነስተን we can determine the solution. ያው እዚህ ጋር ይሄኛው ኦሪጂናል ፎርሙ ኦሬዲ ካለን ዲተርማይን ማድረግ የሚጠበቅብን እኛ is the constant r. የታወቀች constant ናት. It's not an arbitrary constant. ስለዚህ if we say e to the power of rx is the solution, it satisfies the differential equation ay double prime plus by prime plus cy is equal to 0. Hence ምን እናደርጋለን? y first derivative እንፈልጋለን which is r e to the power of rx and the second derivative which becomes r square e to the power of rx. Then substitute በማድረግ we can determine r. substitute ስናደርገው ይሄ ይመጣል. then e to the power of rx as a common ብናወጣት ar square plus br plus c is equal to 0 ይመጣል. ስለዚህ from this ሁለት አማራጮች ነው ያሉን. e to the power of rx is equal to 0 or ar square the second term which is ar square plus br plus c is equal to 0 ነው ያለን. ያው we know that ይሄኛው መቼም ትሩ አይሆንም for any value of r. ስለዚህ ይሄኛው መቼም ትሩ ስለማይሆን ይሄኛው ነው ኮንሲደር የምናደርገው. እንደምናየው this is a quadratic equation. በቀላሉ using the quadratic formula we can solve minus b plus or minus the square root of b square minus 4ac over 2a. በዚህ መሰረት ለአር ሶልቭ ካደረግን በኋላ substitute በማድረግ we can have the general form of the differential equation ማለት ነው። the general solution of the differential equation. This equation is known as the auxiliary equation. Quadratic equation ላይ እንደምናውቀው depends on the determinant which is b square minus 4ac. b square minus 4ac greater than 0 ሲሆን which is the first case ሁለት real root ይኖረናል. Then y1 becomes e the power of r1x and y2 becomes e the power of r2x. Then taking the linear combination of these two we can find the complementary solution of the differential equation. ሁለተኛው case ደግሞ if the determinant is equal to 0 y1 is equal to e the power of rx ያው አንድ root ነው የሚኖረው and y2 is equal to x times e the power of rx. So again taking the linear combination of the two we can find the complementary solution. Case 3 ደግሞ ለየት የሚለው if the determinant is less than 0 ያው complex root ነው የሚኖረን r1 is equal to alpha plus beta I and r2 is equal to alpha minus beta I where alpha and beta are given in terms of a and b. ስለዚህ complementary solutionችን የሚሆነው taking the linear combination of y1 and y2 which are e the power of alpha x cos beta x and e the power of alpha x sin beta x. በዚህ መሰረት we can find the solution of second order ordinary linear homogeneous differential equations. በመቀጠል እነዚህን ኤግዛምፕሎች እናያለን። የመጀመሪያው ያው our first step is to determine the characteristic or the auxiliary equation which is እንደምናየው it's r square minus 5r plus 6 is equal to 0. ስለዚህ this implies that ያው ፋክተራይዝ ስናደርገው r minus 2 times r minus 3 ይመጣል። ያው plus b is equal to minus 5 and the product of two numbers 6 የሚመጣ the sum of two numbers minus 5 የሚመጣ ብንፈልግ ማለት ነው which is equal to 0. This implies that r1 is equal to 2 and r2 is equal to 3 which implies that y1 is equal to e the power of 2x and y2 is equal to e the power of 3x. Then the general solution which is the complementary solution will be the linear combination of the two which is c1 e the power of 2x plus c2 e the power of 3x. ይሄ ይሆናል ሶሉሽናችን ማለት ነው። ለቢም similarly we find the auxiliary equation which is r square plus 8r plus 16 is equal to 0. ስለዚህ እዚህ ጋር again factorize ስናደርግ it becomes r plus 4 the whole square is equal to 0 ይመጣል ወይም r plus 4 times r plus 4 is equal to 0 ይመጣል. This implies that r1 which is equal to r2 is equal to minus 4. The second case ቅድም እንዳየነው our solution becomes የመጀመሪያው ሶሉሽናችን it's e the power of minus 4x ሁለተኛው ሶሉሽናችን ደግሞ y2 is equal to x times e the power of minus 4x. So taking the linear combination of the two we can find the complementary solution which is c1 e the power of minus 4x plus c2 times x e the power of minus 4x. ለሶስተኛውም similarly auxiliary equation እናወጣለን which is r square minus 4r plus 13 is equal to 0. ይህን ፋክተራይዝ ከምናደርግ ያው ፋክተራይዝ ለማድረግ ብንሞክር ቁጥር አይመጣልንም። ስለዚህ ምን እናደርጋለን ዳይሬክትሊ ፎርሙላው መጠቀም እንችላለን which is minus b plus or minus the square root of b square minus 4ac over 2a ማለትም a is equal to 1 b is equal to minus 4 and c is equal to 13. ስለዚህ substitute ስናደርግ finally a plus or minus beta I form ስንጽፈው 2 plus or minus 3i ይመጣል። ስለዚህ from this alpha is equal to 2 and beta is equal to 3. ስለዚህ ሶሉሽናችን ምን ይሆናል ማለት ነው y1 is equal to e the power of 2x cos 3x and y2 is equal to e the power of 2x sin 3x. Then taking the linear combination of the two we can find the complementary solution ማለት ነው።